David Smith here with one more Flipped Classroom math video. 3 tips before we start. First, remember that you can slow down or speed up the playback if that helps you follow along. Second, you could turn on the captions and watch my words go by on the bottom of the screen. And last, you can pause the video at any time to catch up with your notes or think about the topic. Today's lesson concerns gradients of linear functions. Let's take a look at some terms first. Gradient is the same as slope. It's the steepness of a line, and we use the letter m as our variable for slope. Now, a more kind of intuitive way to understand slope is its rise over run. So it's a mathematical quantity, quite frequently a fraction, that represents how much you go up from one point and how much you go over to get to the next point. So here's an example of a linear function. It's graphed for you, and it goes to the point 1, 1 and 5, 3. What is the gradient of that line? Now, a qualitative approach to that is to just simply draw a right triangle. So we're going to go 1, 2, 3, 4, 5, and then over. There's my right angle. Now all we need to do is figure out what our rise is and our run. We're going up from 1 to 3. So this is 2. Our rise is 2. And our run, that's the x direction, we're going from 1 to 5. So that's 4. So rise over run, our m, is 2 over 4, which equals 1/2. That's a basic slope calculation. Okay, we have a formula for this. Gradient equals y2 minus y1 over x2 minus x1. And this is for 2 points, x1, y1, and x2, y2. So if you have 2 points, you just plug your values from your 2 points into this formula, and that gives you the gradient. So here's one, and I want you to try this plug-in step. Between the 2 points, 4 minus 3 and 6 negative 7. Find the gradient between those 2 points. Okay, one thing you can do to make sure you don't mess up the plug-in step is before you start doing anything, you can label your points, x1, y1, x2, y2. This helps not get confused. So then my plug-in step is my y2 minus 7 minus y1, negative 3. And notice how y1 is negative 3 and there's a minus in the formula. So I have minus negative 3 on the top. Then I plugged in my x2 minus x1. I get 6 minus 4 on the bottom. Crunch my numbers. Minus 7 minus negative 3 is minus 7 plus 3, which gives me minus 4 over 2. My slope is negative 2. A negative slope or gradient slopes down to the right. Gradients show up in problems that at first appear to have nothing to do with lines and graphs. However, any linear function has a gradient and can be graphed. So let's take a look at this one. One day last week, 4 people exchanged US dollars for Canadian dollars. And here are those 4 transactions. You can see how many US dollars they had, how many Canadian dollars they got when they did that exchange. Now the question here is, find the gradient and explain what it means. So this is a little tricky. I don't see a line with a slope here. I just see a bunch of pairs of numbers. However, we can treat these as points. Now, this is an exchange on one day, so we can assume that the exchange rate is the same, and so we can plot the gradient. Now, I want you to pause the video, think real hard, and see if you can figure out how to plot the gradient for this table. All right, so here's what I did. I just wrote my gradient formula there from the last board, and I did some plugins. I treated this as x2, y2, and this as x1, y1. But the truth is, you'll get the same result no matter which 2 points you pick, okay? So some of you might have done different points. You should still get the same answer I get. So here we go. I did my y2 minus y1 over x2 minus x1, did my math, simplified down, and I got my gradient is 1.25. Woohoo! Okay, and explain what it means. So what does that mean? Think about that for a sec. Okay, let's see how you did. What this means is the exchange rate between US dollars and Canadian dollars is 1.25 Canadian dollars for every US dollar. So that means if you walk into a bank and you give them $1, $1 US dollar, you're going to get $1.25 Canadian back. All right, let's do some work with gradients. So there's two cases that I want to explore on this board: parallel lines and perpendicular lines. And the way we relate those two is by using their gradients. So for lines L1 and L2 with gradients M1 and M2, so we got some notation going on there, keep track of that. The first condition is L1 is parallel to L2. That's the symbol for parallel to. L1 parallel to L2 if M1 equals M2. So that means two lines are parallel if their gradients are equal. Parallel lines have same gradient. That makes sense. They have to move along like this. They can never cross. Another thing people say about parallel lines is that they never meet. Okay, check this out. L1 is perpendicular to L2. That's the sign for perpendicular. L1 perpendicular to L2 if M1 times M2 equals -1. So two lines are perpendicular if you can multiply their gradients and get -1. So the product of the gradients of perpendicular lines is -1. Now, there's an interesting way to look at that, and that's called this idea of the negative reciprocal. And what I did is I just took this equation that we got from here, and if I rearrange it and solve it for M1, I get -1 over M2. This is the negative reciprocal of this one. So another way to talk about the way the gradients of perpendicular lines relate is they are each the negative reciprocal of each other. So you can just take, like if M1 has a slope of 6 over 5, then M2 is going to be -5 over 6. I flipped the fractions and I made it negative. So that's for perpendicular lines, and we'll use that trick quite a lot. All right, let's do some calculating. Okay, I've given you 4 lines, L1 through 4, and I've given you 2 points on each of those lines. So the first thing I want you to do is pause the video and really do this. You need some practice with the slope calculations. Find the slopes of each of these 4 lines. That should be nice and quick. So go ahead, pause the video, and let's find 4 slopes. All right, let's see how you did. I didn't show steps. This is stuff you should be able to do. I have 2/3, I have -2/3, I have -2/3, and I have -3/2. So those are my 4 slopes given these 4 lines. Now, if you didn't get that, I want you to pause the video and take a look at your work and see how you messed up, because we want to make sure you can do those calculations. Okay, so now I'm assuming that you've got these same 4 slopes. I want you to pause the video and tell me if you can say anything about the relationships of these 4 lines to each other, based on what we did on the last board about parallel and perpendicular lines. All right, here's what I get. L2 and L3 are parallel. L2, L3, they have the same slope, -2/3. Parallel lines have the same slope. L1 and 4 are perpendicular, as noted there. The slopes are related by the negative reciprocal. So 2/3, -3/2. Now, if you multiply these two together, you're going to get -1. Now that you've watched the video, take a moment to write down any questions so you can bring them to our next class. Always remember, you can watch the video again to deepen your understanding. If you enjoyed the video, please click like and subscribe.